Hello students. In the last class we had seen the velocity and position phasor. Something very small that I felt that point of time I didn't discuss. I thought I'll discuss in this video only. So let me discuss this a very small thing. It's nothing, just something guys that you should remember is what the standard phasors. Okay, standard phasors and the phase angles in those cases remember. Okay, why remember guys? Because it saves a bit time. Okay, so I would advise that you can remember. If you can remember, that would be great. Okay, so the first thing is guys, the first one, that is when the particle is at mean position mean position particle is at mean position and going towards positive extreme going towards positive extreme. So in that case guys, what we can say, like, this is your, let's say, this is your uh, axis guys, on which it is going to oscillate, and this is your positive extreme and this is your negative extreme. So the particle is right now here and guys pointing towards what, this side. So the phasor of this we have seen in the previous problem that we have discussed. I can locate this here guys, saying like that our phasor would be what, somewhere here. Okay, so from here the beginning will happen. This will be your imaginary particle. Okay, and this will be what guys, your real particle. Okay, I hope you're getting my point guys. This will be our imaginary particle and this will be our real particle, and the body is going to start like what, this clockwise motion. Okay, the imaginary particle is going to uh, revolve around this circular path guys with the angular velocity omega. So that is the first thing guys, okay, that you have to keep in mind. Now coming to the second one, that is what guys, and of course in this, if I want to write down the velocity equation also, sorry, the equation of SHM, that will be what guys, x is equal to a sine omega t if x naught is equal to 0, otherwise x minus x naught is equal to a sine omega t. Okay, and guys here phi, the phase angle, will be what, 0. Okay, so that is the first case guys. Okay, now coming to the second case. The second case is the second case is if the particle has reached to positive extreme. Okay, if it has reached to what guys, the positive extreme. Okay, so if you see, again I'll just make it. Okay, let's say this is minus a, this is plus a. Now the particle has just reached guys what, here, and the velocity at this moment is what, 0. Okay, and it is going to return back after that. Okay, so this is the scenario guys. So if this is the scenario, the we have seen guys, the phase angle comes in a unique value. We have discussed all those things earlier in the problems, if you remember. Okay, so here what I can do, I can, 1 minute guys. Okay, so like this way we can make it, and I think, okay, I hope you understood guys, so I'll just make it. Okay, so in this case here the imaginary particle would be, and your real particle will be what guys, at the same very place, the same position, your real particle and imaginary particle both will be what, coinciding, because then only the shadow will be what, getting formed on the x-axis. Okay, and guys in this case what we will write, x is equal to what, a sine omega t plus pi by 2, and if x is equal to 0, of course x not equal to 0. Okay, if that is the case, otherwise x minus x naught is equal to what guys, it is equal to how much, a sine omega t plus pi by 2. Okay, pi by 2, and phi will be what guys, pi by 2. And this we can see also guys, that if you see from the reference, okay, this is our reference line, you can say. So from reference line the angular position is what guys, pi by 2 of the imaginary particle. So we can say the phase angle will be what guys, pi by 2 only. Okay, now coming to the third case. Third case would be what guys, that is particle is at mean position and going towards negative extreme. Okay, negative extreme. So in that case what we can say guys, if I make the phasor, it would be simply like, say this is the positive extreme, this is the negative extreme. Okay, and this is your plus a and this is your what, minus a. So the particle would be right now here. Okay, and it will be aiming towards this guys. Okay, it will be aiming towards this. So if I make the phasor of this, how it will look like guys, it will look like here, that this will be the what, this would be the phasor guys. Okay, this would be the phasor, and your imaginary particle would be here. Okay, and real particle would be here. I hope you can see guys, this will be imaginary particle and this will be what, real particle, and like this way the picture would be. Okay, and guys this is your reference line, can you see? So from there if I show you the angular position of the particle at t equal to 0 is how much guys, pi. So what we can say, we can say that x is equal to nothing but what, x, sorry, a sine omega t plus pi. Okay, that we can write, or x minus x naught is equal to a sine omega t plus pi, and the phase angle will be how much guys, pi, of course. Okay, so that is the third case. So these four cases guys, the fourth one I'm going to write only. These four cases you have to remember, and I think now it will uh, get fit in your mind, I guess, by explaining all these. I feel so that you will get the idea. So here guys this is like this way and this is like this way. Okay, and this will be what, this will be your plus a and this will be your minus a. So the fourth case guys I forgot to write. So fourth case is what, particle is at negative extreme, negative extreme, negative extreme. So in this case also guys, the phase angle value comes in a unique value only. Okay, so in that case if you see what is going to happen, the particle is going to be available here. Okay, and it is going to move then this side. Okay, just let me choose Michael guys. Okay, yes, so it is going to move in this direction guys. So in this case if I make the phasor will look like what is, that it is at a positive extreme. Okay, sorry, negative extreme, So of course guys, right now the situation would be what, the phasor would be like this will be our imaginary particle and this will be our what, real particle. Okay, imaginary particle, real particle guys. And if you see from the reference line, if you see from the reference line, it has moved this much angle, which is what, 3 pi by 2. So we can say that x will be, simply we can write as x, we can write as a sine omega t plus 3 pi by 2, or x minus x naught is equal to a sine omega t plus 3 pi by 2, and phase angle is 3 pi by 2 guys. Okay, so these four cases guys you have to keep in mind, these four cases you have to keep in mind, these are very very important. Okay, so now the next thing that I'm going to start guys, that I will start in the next lecture only, okay, is the energy analysis. Okay, so just I'll put the heading right now only, that is what guys, the energy analysis, energy analysis of a particle performing SHM, performing SHM. Okay, so I'll see you in the next class guys discussing this. Okay, thank you.